Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is IBM MQ JMS with ITX. Feel free to reach out to me on popular social media channels at Paul Brett Tech. In this practical demonstration, I shall create maps that both put and get messages from an IBM MQ queue using the IBM Sterling Transformation Extender ITX JMS adapter. I shall then create and deploy a system to the ITX Launcher to run a map on the arrival of a message on the queue. Let's start the main demonstration. As you can see, I have a notepad open with some basic instructions that I'm going to use. You will find these instructions in the text of the video. First of all, I've got a remote connection to a machine called VM16X and within this machine I have MQ installed. I believe it's version 8, and I have two versions of Transformation Extender installed. One is version 9 and the other is version 11.02. So in the instructions, first step, ensure that WebSphere MQ is set up and a queue manager called JMSQMGR is created. The queue manager should have a 50 meg size limit. Well, that's for bigger messages that I might want to do later, but for now it doesn't really matter. But here we go. Over on the remote machine I have MQ set up. I have a queue manager called JMSQMGR. I have a queue called test.q.1, which is mentioned in step 2 here, create a queue test.q.1. Again, changing the default size to 50 megabytes. Not really necessary here because I'm only using small messages. It says here, ensure that all environments have the class path and lib path as follows. Now you can either set class path to point to the com.ibm.mq.allclient.jar, or you can add that particular file to the dtx.ini in the external jar files section jar1 equals, and I believe that's what I've done. If we open the ini file and search for jar1, you'll see that I have that line in my dtx.ini file. This ensures that I don't forget to set the class path and the maps will work in the Design Studio as I expect. Okay, next part of the instruction is to modify a file called jmsadmin.config. Now here, this file is found in the MQ installation under the Java directory in a folder called bin. I'm going to open that file now, and I've already edited this file, but basically the only line that needs changing is provider_URL. I've changed it to file:/c:/JMS. The default is pointing to, I think, JNDI_context or something like that. But anyway, I'm using a different to the default, and you'll see that I'm also using a similar string in my map later. Okay, if we go into that directory, there's currently no bindings. It's a .bindings file that we're going to be creating in the next step. So let's close the config for the moment. The next step is to run JMSAdmin to create the queue connection factory and queue as follows. So let's get that program running. Okay, we're in that program now and the prompt is initctx. So I'm just going to copy in these two lines to define my queue manager and my queue. Both done, and now I type in end to exit that program, and in the background in the JMS directory you will see there's now a .bindings file. That's the end of the setup from the MQ side. Over in the map you will see that I have a project called MQ_JMS. Within that project I have example.mms. Within example.mms I have three maps. The first one I want to look at is test put 1. This map has two cards, an input card which has the echo adapter sending in just the word message. The output card connects to the JMS adapter. Let's have a look at this command in detail. We have an initial context factory URL, and I'm using file:3/C:2/JMS. Now I've actually found this works with just one /, but technically we should use two here. Next one is initial context factory, and it's com.sun.jndi.fscontext fs factory. A long mouthful, but it has to be exactly that. Then we've got -qn for the queue name and -cfn for connection factory name, which matches my queue manager. And finally a -t for a trace. This is going to create one message on the queue. So let's have a quick run of that now. If we go back to the Explorer and look at the queue, there's currently no messages on the queue. And if we build and run this map and switch back to the queue manager, we might have to do a quick refresh, but there is now one message on the queue. I'm going to run that another 3 times, and we'll switch back to the queue manager, and there is now 4 messages on the queue. I want those for testing my output maps in a moment. Okay, so that's putting a message onto the queue, all working absolutely splendidly. Let's look at test get 1. The cards are the same as test put 1, except the adapters are reversed. On the input side now, we're also using the same connection string with one small addition, -qty1 to fetch one message. I've got the on success set to do delete, so this will dequeue the message every time this is run. On the output side, we're writing to a file called output.txt, and the output is going to come into this window here when this map runs. Build, run, and here we go on the output side. It's coming in as XML. We have message, we have body tags. The body says that the type is going to be bytes, and we see some bytes there in between the two body tags. Now this doesn't look like the word message that we sent in, and this is because it is base 64 encoded. So I've made a second version of the map called test get 2, and in that the input card structure has been changed to parse that message structure that's coming in, and the actual bytes will appear in the object data here below body. And on the output side, I'm using base 64 to text function to decode that message, still writing to the same file. So if I build and run that map, you will note that the output of this map is message. So I've got my initial message that I put in back out again. So that's getting and putting a message to JMS MQ using the Design Studio. Next step is to create a launcher-based system to do exactly the same, but trigger when a message arrives on the queue. Back to our remote machine now, and I've created a system file which I shall now open with the Integration Flow Designer. And within this system file I have defined one map, and within the launcher settings I've set the input to trigger every time there is a message arriving on the queue. I've done this by turning the source event from off to on. The connection string is exactly the same. The map that I'm using is test get 2, so this is going to be reading in the structure, parsing that XML data, using the base 64 to text function, and just spitting out the message it receives from the queue. The map itself is going to create a unique backup of input, the output is going to be sent to sync, and I have a unique audit log turned on. Let's quickly look at the queue. You'll note that the queue currently has 0 messages in it. And we have the launcher monitor running in the background, ready to fire up as soon as the service starts. So I'm going to start the launcher service now. The MSL has been generated and deployed to the appropriate location. And there we go, the monitor has kicked off. It's currently showing no maps running. Now if I double click on my test1 put map to put a message on the queue, move that window out of the way, you should see a green dot appearing on the monitor screen here as it picks up that message. It might be difficult to see, but it is there just floating above the mouse. You will note some logs have been produced for the launcher startup, and if we go into our map directory again, you will see that we have a test put1 mal, the adapter trace. We have a test put1 log, the audit log. That's for when I did the put message. We also have a test get to mtr trace file, tracing the input content, a mal file, which is the adapter log, and a unique audit log for the execution, as well as a .back file showing the content retrieved from the queue. If I drag that content into Notepad, we should find that it contains the XML code, because we're not getting the result of the output card here, we're only getting the result of the input card. Remember that I'm sending the output card to sync, but the output card would contain the word message. So there we go. We have our map running under launcher. Every time a message is put onto the queue, like so, a new map runs and a new .back file arrives in this directory showing the content of the input card has been backed up. I want to make you aware of some changes that are required when moving to ITX 11.02. The same map without any changes should run, but there are some configuration changes required in the background. Now the JMS adapter has moved on. It no longer conforms to the JMS 2.0 specification and now uses JMS 3.0. So the bindings we created with the JMS admin program are no longer any good. If I download a newer MQ client, within the bin directory I find a new script called JMS 3.0 admin. And if I run this script exactly the same as I ran before and paste in those 2 lines that I'd pasted before, it will create a new .bindings file for JMS 3.0. Additional changes. The jar file that we referenced using ITX 9 or 10 is no longer suitable for use with ITX 11. Instead, we have to use the com.ibm.mq.Jakarta.client.jar and these additional support jars, fs context and provider util. I've referenced them in the config.yaml, no longer the dtx.ini. That's no longer used. We're using config.yaml and we have those 3 jar files referenced. So let's get the exact same map. I'm dragging it from the exact same directory and it's the same file that I created in ITX 9. You will note that in my queue I currently have no messages, and under test put 1 I don't even need to build it, I can just run the map. The map completes successfully and in our queue we find 1 message in the queue. Again, I can run the get map. I don't need to build it again if I don't want to. I can just run the map. It is completed successfully, and if I look in the directory we have an output.txt file, and if I open that it's got the word message. So in summary, once again, to use ITX 11 with JMS against MQ, you need to use 3 alternative jars instead of the all client jar we used with the earlier ITX version, and you need to redo the bindings using the JMS 3.0 admin script after modification of the JMS 3.0 admin.config file, ensuring that the bindings location has been correctly specified as C:/JMS. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.